Hello everyone, this is Ashish Bhatnagar, Assistant Professor, Computer Science Department, IMS, Ghaziabad University Course Campus. Today, I would like to describe the concept of stack implementations, specifically how we have just to implement the stack. So there are n numbers of ways we have just to implement the stack, like for example, the conversion of postfix to infix and postfix to prefix. So today I am considering the example, the conversions between the postfix to infix and postfix to prefix expressions. So if we have given any expression, so how we have just to convert the expression. So there are three ways basically: postfix to infix, infix to prefix, prefix to infix, and much more. Okay, so what exactly the meaning of postfix to infix? So here we have just to consider the postfix to infix involves transforming our postfix expressions into an infix expressions, and in postfix notations operators follows their operand, whereas in infix notation operators are placed between the operands. So we should know about the meaning of the postfix and prefix and operands meaning. So accordingly, here you have just to consider the meaning of postfix expressions means reverse Polish notation, it is also called. And infix means we have just a normal algebraic notation, for example a, for example plus and b. This is the infix notations. And if we want to convert the infix into the prefix, so of course we have just to define the plus notation before the operand, like plus a and b. And for example, if we want to convert the infix to the postfix, so we have just to consider a, b plus. So this is a very simple way, but what's the exact strategies to implement, and what is the exact algorithm to implement such type of conversions in the stack implementations, right? So we have to consider the algorithm for postfix to infix conversions. For this, the first step is we have just an empty stack and scan the postfix expression from left to right. If you have given any expression, so we have just to scan the expression from left to right, and if operand is found, so we have just to put it onto the stack. And if operand is found, so pop two operands from the stack and combine them in an infix format, like operand 1, operator, and operand 2. So this is the way we have just to show the performance of the infix, because this seems just like as an infix expressions, right? And push the result back onto the stack finally, and continue until the expression is scanned completely. If expression is very large, so we have just to do much time to conversions, and if the expression is minimum, so accordingly the expression will be proceed now. So the result in the stack is in the infix expression finally, right? For example, we have the one expressions, this is the postfix expression, and we want to convert this postfix expression into the infix. So we have the given expression a, b, c star and plus into the infix. So what we have, because a, b, c both these three are operand, and according to the algorithms we have discussed, so we have just to put a into the stack, accordingly b onto the stack, accordingly c onto the stack, because we have given continuously the operand in the given expressions. So accordingly we have just to set the operand into the stack. So this c is the currently top of stack values in the stack, fine. So after that we have encountered the star, this is not the operand, this is the operator. So we have just to push c and b or b and c from the stack and combine like this b into c, okay, as given the algorithm. So push back this complete, you can say the expression onto the stack once again. So we will find out a, b into c. Yeah, so this is my update. And in this case we have just to find out the top of stack is b into c, fine. After that we have just to find the plus, this is also operator. So again we have just to pop out the a and the next expression b and c from the stack and combine them like this, a plus b into c. So this is the thing, this is the infix notations, infix found, you can say, okay. So this is a conversion from how we have just to convert the postfix into the infix. So the given expression is the infix, sorry, postfix, and we are just to find it out the expression into the infix, okay. Let us consider another examples. The same examples here. We have just to given the expression AB plus C star into the infix. Okay, so we have just to convert the same concept as we have just discussed in the example number 1. So we have read A is an operand. So push A into the stack. Accordingly, push B onto the stack because we have a 2 operand, which are just to find it out, and after that we have the plus, which is operator. So we have just to popped A and B from the stack and from the expression A plus B. Push back A plus B back onto the stack. Okay, come to the another operand, which is C. So according to the algorithm, we are just to push the operand C onto the stack, and after that we are just to find out the star. Star is operator, so we are just to pop it out A plus B and C simultaneously from the stack, and we are just to given the expression A plus B into C. So push A plus B into C back onto the stack. So again, this is the final expressions, which is the thing, it is an infix notations. Okay. Another concept is, another conversion is postfix to prefix. How we have just to convert the given expression which is in the postfix, and I want to convert the postfix to the prefix notation. In a simple example, postfix means like if you have A, B, okay, plus. So this is the postfix because we have just to given you can say the operator after the 2 operands, and I want to convert this expression into the prefix like this, A plus A and B. Yeah, so this is my ultimate goal. So how I can do? So postfix to prefix conversions refers to the process of transforming a postfix expression, which is also known as reverse Polish notations, into a prefix expressions, also known as Polish notations. So in postfix notations, operator follow their operand, while in prefix notation, operator precedes their operand, just like a given example in this concept. So what is the algorithm? The step first scan the postfix expression from left to right, and if operand is found, push it onto the stack, and if operator is found, pop 2 operand from the stack and combine them in the prefix format, just like that given in the bold notations, like operator, operand 1, operand 2. Again, once again, operator, operand 1 and operator. Operator represents a postfix operator, and these 2 operands should be any type of, and push the result back onto the stack. So continue this process until we have just to scan the expression completely, and finally we will find the result in the prefix expressions. Okay, consider example. So this example, ABC star plus into the prefix expressions. So we have given the postfix. This is the postfix notations because we have given all the operands in a one side, and the rest of the operators are given after that. So it's okay. So we have just to find the stack. Operand A, operand B, and operand C. So accordingly, we have just to push operand A onto the stack, operand B onto the stack once again, and operand C onto the stack once again. So currently the top of stack is C. Okay, and find out we have the star is encounter the star. That means we have just to pop it out B and C and combine them like that, star BC, and push onto the stack once again. So we have just to push into the stack. A is already included in the stack, so the top of stack value is star BC, and after that we have just to find out the plus operator and pop A star BC, and as just because we have just to find out the plus operator, so we have just to pop A and star BC, combine them like this. So this is the plus A star BC. This is the thing, this is the given, you can say this is the required prefix notation, and we have just to check it out. The plus A star BC is the finally prefix form, right? Okay, another example. This can be done when if we have the large expressions. That means we have required the numbers of we have just now the numbers of operands and numbers of operators so large. Okay, for the larger expressions. So this is the way. This is a step how we have just to read the operand and operator onto the stack, and this is the perfect, you can say, the steps for the larger expressions. And if we read all the steps accordingly, so we will find out the final expressions is like this. like minus star plus AB minus CD star divided EF plus GH. Okay, so consider read A. Okay, set the A onto the stack. Read B, again set the B onto the stack. Read plus. So yeah, as because we want to convert the prefix, so popped it out plus AB. Again read C. So after that plus AB is the initial value which is pushed back onto the stack, and C is again pushed onto the stack. We have just to find out a D. Yeah, of course D is pushed onto the stack. So we in this given stack, the top of stack value is D, and the rest three expressions are reside inside the stack, right? And okay, we have just to find out the minus is operator. Okay, push back of the C and D with the apply, after apply the minus operator as in the prefix notation. So these are two expressions once again, and again push back this two expression into the stack when we have just to star is here. So star is here, and star is again the operator. So we have just to set the star with this expression. So this expression is a complete expression, and if you find out any operand like E, so again push back this complete expression into the stack with the E. So there are two parameters like this and this. The same process will continue until we have just to scan the full expression from left to right, and finally we will get this output which is in the prefix expression. So my dear students and friends, you have just to check it out how we have to do the conversions for the implementation of stack with the simple expression and the large expressions. Okay, so this is the key explanations. When you read an operand ABC, you simply push it out to the stack. If you encounter any operator, so you are just to pop out two operand from the stack, combine them either in the prefix or the postfix notations, and push back again onto the stack, and this process continue until you reach the end of postfix or prefix expressions, which is the required result, right? So that's a way to do this particular task. I hope you have just to clear all this concept. So thank you so much.